Hello, in this video I'll be describing the automated bus structure that I have implemented within my game Good Clown Bad Clown. To begin with, I would like to highlight the bus structure itself, located on the left hand side in the Project Explorer. Within the master mixer hierarchy, you can see that I have different bus structures for objects, pass-through, reverb and sidechain. Moving on to the actor mixer hierarchy, you can see that there are a number of different pieces of audio associated with different game objects. So here we have a balloon mixer, fire mixer, duck mixer, and a fart mixer, to name a few. What the bus structure actually does is, for the most part, it will automate any parametric EQ ducking that I have implemented within the game, so that when certain pieces of audio are playing at the same time, others will take precedence over other pieces of audio. So for example, in the game, when you're in the shooting level, ducks will occasionally quack to draw the user's attention, to remind them that they still have targets to shoot at. But when you also hit another target, for example when you pop a balloon, that will also make a sound. What I wanted to do is, whilst the ducks were quacking, I wanted the actual objectives being destroyed to have precedence over the ducks quacking. Whilst it's not a drastic change in volume, it provides a subtle shift in removing the low frequencies from when the ducks play, so that it sounds quieter but it still sounds more natural. So that's what this graph here will show down at the bottom with the RTPC values that I have implemented, so that anything that's below 48 or negative 48 will be cut off essentially. So let me just show an example of how this works. So the audio may not work best on YouTube, but I will give it a go anyway. So here is the duck quacking sound, or one of the random ones, as you can see from the soundcaster, and this is the sound of a balloon popping. As you can see, when the balloon pop sounds happens, the graph, the indicator on the left actually moves up to show that sound is being cut off. So when I play both at the same time, which hopefully will happen, there was a sudden, very slight shift in the balloon taking precedence over the duck. It's not a massive amount, but you can tell that the balloon takes priority over the duck sound. And each piece of audio also has positioning attenuation attached to it. So at the moment, because Unity is obviously different from, this is a Unity game, as opposed to an Unreal game, the max distance is quite considerably less than what you would find in Unreal Engine. So I have that currently at 25 because this is a VR game, and to make it more immersive, the sounds aren't particularly far away either, because the game levels aren't entirely, they're not massive, for example. And so all this really does is, when the player gets past 25 game meters in the game, it will slowly reduce the volume of the actual audio that they hear, and then when they pass 25 meters, they won't be able to hear the audio anymore. But because I'm using 3D spatialization for the audio, the user can hear it as if it was a real life scenario, so you'd still be able to hear the audio. If the object was on your right side, you'd hear it on the right, left side left, behind you, forward, wherever the game object is to the player's position in the game. And that's essentially what I wanted to highlight in this video. Thank you for your time, and have a great day.